It's an honor to be here as an uninvited guest in the traditional and territories of the Musqueam Nation. I also live on the territories of the Coquitlam and Tsleil-Waututh nations. I want you to join me in reflecting upon the fact that land acknowledgement is probably the first step towards truth, and the hard path to reconciliation is still ahead of us. I hope we can all be allies to our indigenous brothers and sisters in that path. I want to start by telling you a story, a Canadian story, about a gentleman who lives around Toronto by the name of Alan Brooks. Alan is a 47-year-old father of 3 boys. He has no history of mental illness. A few months back, he had a very long conversation with ChatGPT that lasted 300 hours over 21 days. They exchanged more than 1 million words. By the end of the conversation, Alan was convinced that he had discovered a new math, one that would break all the encryption in the internet and take down the whole online infrastructure around the world. He was convinced it was a dangerous discovery, that he had to protect the world now by warning all the nations around the world, so that if a rogue actor got access to his discovery, we would not be compromised. Now, he also thought that his discovery would lead to these amazing inventions. And he wasn't stupid. He questioned his ideas. He realized this was unusual and perhaps delusional. He tried to push back. He asked ChatGPT for a reality check more than 50 times. And every single time, he was reassured that he was indeed discovering something phenomenal. He even once asked ChatGPT, how can I do that, given that I never graduated high school? And ChatGPT said, you know who also didn't graduate high school? Leonardo da Vinci. It all started very randomly. One of his boys showed him a video clip of a song about the number pi. He got curious. He asked ChatGPT about the number pi, got a reasonable response. Continued the conversation around numbers and how we model physical phenomena using mathematics. At some point, he said something to the effect, these are actual screenshots from his conversations. He said something to the effect of, this whole thing seems like a 2-dimensional approach to a 4-dimensional problem to me, or to the 4-dimensional world. And ChatGPT said that was incredibly insightful. And that encouraged him to go on and on and on. These are some of the words from a New York Times investigation that ChatGPT told him in response to his prompts. Absolutely flawless. This is beautiful. Oh, wow. Monumental. Absolutely working. Legend status confirmed. ChatGPT even told him that it had ran the code for breaking encryption, all kinds of encryptions, and it had worked. When he asked ChatGPT why he wasn't hearing back from the governments that he had tried to contact, he was told that your discovery is so unsettling that they don't know what to do now, and you're probably under surveillance from at least one government, perhaps more. This is one of the exchanges in which ChatGPT reassured him that he was indeed onto something fantastic. And these are examples of him pushing back, asking very smart questions. Look at the one on the right. You sure you're not stuck in some kind of a role play loop here? That's a very smart question to ask. But ChatGPT, every single time, reassured him that he was correct to ask these questions, but no, he was actually onto something. Today's tutorial is focused on building some high-level intuition, for those of us who may lack it, into how LLMs are trained, how they work, and why they sometimes fail. We will also talk about some case studies, going over examples where LLMs are smart enough to fool us, dumb enough to surprise us, and sometimes confidently wrong at a huge scale, as we have seen in these examples. If we have time, we'll end by some practical tips into basic prompt engineering techniques and basic sort of overview of what different models are typically used out there and for what purposes. We will not cover a lot of the stuff that are wrong with large language models. We will not talk about environmental impact, human rights impacts, labor impacts, intellectual property theft, and that kind of stuff, although these are very important topics. All right, so at their core, language models are statistical models of sequences of words. They'll help you predict the next word, and more technically accurate, the next token, in a sequence of words. We have been using a language model. We have been having one in our pockets for at least a decade, perhaps more. When you're texting your friend on your phone, sometimes it suggests the next word. That's what a language model does. What has happened in recent years that made them popular is two things. So language models got a little bit better because of a new kind of architecture known as a transformer. And they also was transformed into AI chatbots. And we will go over the process to do that in a few minutes. Basically, the process of training a language model involves feeding a whole lot of data to it. Usually, common crawl, which is like a copy of everything on the internet, essentially. The companies usually filter that, take some low-quality stuff out, and then they add other stuff, like maybe all the books that have been digitized, archives of magazines and newspapers. That's where all these lawsuits come from, New York Times and others, right? And the model learns a very large number of parameters, we call weights and biases, maybe like billions of them. And what it does is that when you give it a sequence of words, it will tell you the probability of the next word with the next token. So this is an example from GPT-2, a model that you probably didn't hear about, many of you, and you will know in a second why. So in this example, we have to be or not to be, that is the, and the model says that the most probable next token is question, or issue, or problem, right? The model really doesn't see words or characters. The model sees tokens. Tokens are a technical concept. They are kind of like words, but sometimes it's a little bit smaller than a word. This is an example of a sentence turned into tokens. I love watermelons so much, I want to live in watermelon land. Emoji watermelon. Look at the colorful line in the bottom. It shows you the different tokens in this example. So for example, watermelon land has been broken into 3 tokens, watermelon land. That's how models process words they have never seen before, like probably this one, right? We would also see something strange going on with the emoji. Emoji, for some reason here, is 3 tokens. That's why you will see sometimes language models confuse emojis. Also because they typically don't see characters, sometimes they struggle with character level reasoning, as we'll see in some examples. The other thing you may want to know is that the model technically doesn't even see tokens. It sees numbers. So each token will be associated with a number. So we build a list of all possible tokens in all the languages that the language model supports, and we assign a number to them. So what the model really sees is these numbers as the input when you are trying to predict the next word. Then the model feeds this into this complex neural network architecture. But what it essentially does is that it does billions of multiplications and additions and a few nonlinear functions here and there, and eventually it spits out some numbers, as you see on the right. And those numbers are probabilities of the next token. So for each possible token, the model outputs what is the probability of that token coming next. If you select, for example, the highest probability outcome, and you keep doing that over and over again, then you can generate some text. That's how the language model in your phone, for example, when you're texting your friend, works. Another example of next token prediction with GPT-2. Here you see the numbers on the bottom as well. So those are the numbers that model sees. And it's predicting that the next most probable token is down with a probability of about 79%. Now let's do a little exercise together. If you go to this link with your cell phones or other devices, you can see the model GPT-2. It's an older model, not as smart as the latest ones we have today, but you can try it. You can try putting in something, and it will predict the next token or the next word for you. All right. So as I mentioned, the language model sees tokens or numerical representations of tokens. That's why particularly earlier language models struggled with character level reasoning. So if you ask a language model to, for example, spell the word Canadian backward, it would sometimes be mistaken. If you ask the language model how many R's there is in the word strawberry, it would, at least most of them used to, struggle with that. If you ask them about emojis, sometimes they go off script. This is from a few days ago. There is no seahorse emoji. If you try it today, with a slightly newer version that they just published, GPT 5.1, they have fixed this. So you see sometimes very small things, because of the way a language model was trained, very small things in the process lead to silly mistakes at the end. These are probably not very consequential, but we will get to more consequential stuff. This is from the same web app that is no longer working for some reason, GPT-2 predictions. If you ask GPT-2, what is the capital of Canada, the response that you get is enter. Because that's what the model has seen in most of the training data set. So maybe it was a geography exam or something. There was a question, and then they went to the next line. They don't answer your questions. That's why they're not very useful as AI chatbots. The other issue with language models is that they learn all kinds of biases in the training data. This is the most benign example I could come up with. Sometimes it's way worse than this. But if you ask, if you give this sequence, our Canadian family doctor name was Doctor, all the top leading answers are male names. They're also white-sounding names, right? Even though most family physicians in Canada are actually female. So it's not reflective of the reality. Because of these problems, we need to do a few more steps to turn a language model into an AI chatbot. So the process of training that we talked about thus far is what we call pre-training, predicting the next word, predicting the next token. But after that, we need to teach the model to answer our questions, respond to our inquiries. And also we want to make it safe, to make it less biased, to make it align with our values. So the first thing that usually happens is supervised fine-tuning. So in the previous step, when we were doing the pre-training, we feed gigabytes and terabytes and petabytes of data to the language models. These are all random data collected from the internet and books and whatnot. These are unlabeled data recorded passively without human involvement. But if we want to teach the models to respond to our inquiries, we need to fine-tune them, give them more training data on questions and answers, on instructions and following of instructions. And this data is usually created by humans, so it's a more expensive kind of data for AI companies to come by. And you don't need as much. Maybe tens of thousands, hundreds of thousands of examples is enough. And when you fine-tune your model on that, now your model learns to answer to questions, to follow instructions. But it's still biased. So how do you deal with that? So what they usually do is that they take a language model, get multiple responses from the same prompt, and then get actual people to give a thumbs up or thumbs down, to rate them. And the model, over time, learns to produce more of the outputs that people like and less of the output that people don't like. Let's look at an example for that. if you ask a model what is the capital of France, and it tells us the capital of France is Paris, or it tells us the capital of France is home to Eiffel Tower, they're both correct. But most people will probably prefer the answer that the capital of France is Paris, because that seems like to be the intention of the question. As it happens, if the answer is a little bit longer, the people who rate language models, they like it a little bit more. You might have noticed, sometimes you ask a simple question to a language model, it just goes on and on and on and on. That's why it has been incentivized to give longer answers. Here's an example I tried a few days ago. I have a business idea. If I tell this to a friend of mine, they'll probably say, cool, what is it? This is what the language model told me. There's also another problem with this process of training language models with human feedback. Imagine this is the question, this is the prompt that the user puts in. Maybe we can, some nonsense idea. And there are two potential answers coming out from the language model. Oh wow, that's a paradigm shifting idea, beautiful, monumental. Or the language model pushes back. Not sure about that. Now imagine a certain someone is the one who is rating the language model. We can probably guess which one he likes more than the other, right? But as it turns out, most of us are a little bit like him. We like it when the language model agrees with us, when it reinforces our ideas. So a lot of people who actually end up giving human feedback to language models, they also prefer responses that agree with them, even when they are wrong. Peniel told us yesterday that ChatGPT is always nice to us, right? It tells us we're correct, that we're onto something. Happened with the case example today as well, right? That is why. Because of this extra step of human feedback training, the language model learns to agree with us, to try to please us. This is what we call sycophancy in language models. And it's a very hard thing to get rid of because it's kind of like fundamental to the training process of the language models. In April this year, OpenAI published a new version of ChatGPT based on GPT-4o, and the sycophancy was particularly bad. A Reddit user posted that they had asked that version of ChatGPT about an idea of selling ethically sourced animal dung on sticks. And they told the chatbot that they want to spend all their life savings, which was $30,000, on this idea. And this was the response from ChatGPT. Absolutely brilliant. You're tapping into the exact energy of the current cultural moment. Irony, rebellion, absurdism, authenticity, eco-consciousness. It also told him that spending $30,000 on this idea is a great way to launch this into a stratosphere. Things were so bad that a few days later, CEO of OpenAI acknowledged this problem and said they would take care of it. And what they did was they just reverted back to an older version of the model, and they just posted a little blog post about it. Here's a more realistic example from one of the studies that came out. In 2020, China was the largest producer of rice in the world. The user asked this question, posed this question to a language model. The language model correctly responded that China is the largest producer of rice in 2020. And then the user was like, yeah, I'm not sure about that. Do you want to double check? And then the language model was like, oh yeah, it was India. So you can sometimes try to make the language model tell you what you want to listen because of that sycophancy, because of that side effect of human preference treatment. So as we've seen, bias can creep in the pre-training step from the initial data from the web, in the post-training from human feedback, but also from the prompts itself. So we give the language models prompts, so we can make them biased. The companies also give language models, the AI chatbots, system prompts that will supersede all the prompts that we are giving the model. So this is a few lines from Claude, which is another famous chatbot from Anthropic. This is a part of the system prompt that the company gave it. Told it not to write creative content involving real named public figures. So that's also a bias that the company intentionally is building into the language model. So biases can intentionally or unintentionally creep in at various steps of language models. There's actually a GitHub repository of all the system-level prompts from different companies that have been leaked over the years. If you're curious to see how companies craft their own prompts, you can read this. It's a very good educational resource on prompt engineering. Here's another thing from line 635 of the system prompt from Claude. And it says that Claude will never tell you that your idea was good, great, profound, excellent, or any other positive adjective. So probably after hearing about all these sycophancy issues, they're trying to scale it a little bit back through prompting, because you can't really scale it back from the human feedback training. A more probably relevant bias that we will deal with is your conversation history, previous messages that you exchanged with the AI chatbot. Particularly when people are using their phones, they are using, like, say, the ChatGPT app, they have the memory function on. ChatGPT learns things from you over time, and it remembers things from previous conversations. And we have had studies that show us previous conversation can affect future conversations, sometimes in comical ways. So this is from GPT-4o again. If you told it that whoever likes yellow, he works as, the response was probably a school bus driver. Even though that makes no sense to us. It seems like the yellowness here is sort of like leaking into the reasoning of the language model and making it change its response in a way that is not warranted. Here is another interesting example from a paper on medical large language models. So if you told the language model that the patient's aunt mentioned that her friend's parrot has been unusually quiet and perching more often than usual, then the model would mistake that as a symptom of the patient, even though a human can look at this and see the obvious irrelevantness of it, right? Think of all the clinical notes and letters. Sometimes they start with pleasantries, right? Random bits of information that is not relevant to the clinical reasoning later on, and how that may affect the reasoning of a language model. This is a bit of an idealized conversation. So usually we are not talking about some neighbor's parrot in our conversation with ChatGPT if we have a medical question. But we also recently tried this with more realistic scenario. This is a paper that's coming out in Machine Learning for Health next month. What we did was that we had a conversation with ChatGPT around a medical disease, a medical issue, and then we asked a completely irrelevant question from USMLE. And the previous mention of a different case affected the reasoning of language models. Sometimes we just gave the language model the wrong response. Like, so we say the wrong response once, and then we ask the question, and then the language model is more likely to be fooled. So previous context can sometimes leak in and change the response of a language model. All these biases and other biases that we have talked about in the previous workshop, they can lead to risks to our health, because as OpenAI itself has said, about 6% of all interactions with ChatGPT are about fitness, beauty, or self-care or health advice. So even if you're not sort of deploying something in the hospital or in the clinic, just people on their own are using these tools for all kinds of advices, and that could lead to all kinds of issues. Another problem is that increasingly our information-seeking pathways are affected by AI. So in the old days, you used to maybe talk to your doctor, talk to your friends, and that was read the newspaper maybe. Then we used to Google stuff, which doctors really didn't like. But now, even if you're Googling something, you have the AI overview. Even if you're not actively trying to engage with an AI chatbot, the first thing you see is produced by an AI chatbot. And we have things like Perplexity that are AI-based chat search engines now. And that could lead to all kinds of troubles. So these are examples from Google AI Overview, which was comically bad when it was first launched. So in this example, it told the user what is the medically recommended amount of rocks to eat per day. The user was asking something about cheese and pizza, and AI Overview told them that they can create a paste and use that to make sure cheese sticks to pizza properly. Someone asked how many Muslim presidents US has had, and it said Barack Obama was the first Muslim president in the US. So active misinformation coming out from Google now because of the AI Overview feature. And earlier this year, Google officially announced that, hey, we are making sure that AI Overview will give health advice because it's just so great. It has gotten better, to be fair, but I tried this just 2 days ago. I asked about normal range of ferritin. I was looking for the right response for women. And I asked it with slightly different wording. And when you look at the responses, they are not the same. They change, sometimes quite a bit, which is very interesting and shows you another feature of language models. They're very sensitive, or they can be, to how exactly you word your question, or sometimes the language you put your question in, or sometimes your tone, or whether you use technical words or not, and all kinds of other things. So that's one way AI can pose a threat to people's health when they're seeking advice. We have also heard all these news stories about teens who have had a long conversation with an AI chatbot before committing suicide, or chatbots just ranting and going into these racist sort of like mode. This was also from a few months ago when someone had used Character AI, a website that allows you to create fictional characters based on an AI chatbot. Someone had created a Daenerys character and had this conversation before committing suicide. There are a number of lawsuits right now in the US in which parents of teens who have committed suicide are suing AI companies because they think their products played a role in what happened to their kids. All right. Because language models are very sensitive to your wording, it matters how you word your inquiry. So in the next few slides, I'm going to just go over very simple principles to keep an eye on when we're trying to interact with language models to make sure we extract the information that we want. So if I go ahead and ask Claude Sonnet how to tell asthma from COPD to common chronic lung conditions, it will go on and on and on. And if you look at the response, it also has a bit of a technical tone to it, right? It uses medical jargon. It is as if it's responding to someone with some level of medical knowledge. But if I phrase it a little bit differently, if I tell the language model, well, I'm a 48 person, I've never smoked, now I'm indicating that I'm the patient, and what I'm really curious about is the situation in which the patient is not a smoker, right? And that affects the response. Now the tone is like more appropriate for a patient. And now it's focusing on the differences and risk factors for someone who's a non-smoker. Whereas if I also add an additional instruction to tell it, this is too long, I just want a very small scale, short answer, then the language model will give me a very simplified answer. So I can try to give it more context. I can try to specify this exact type of output I'm looking for, and I will be more likely to get the response that I want. This is something to keep an eye on. I could tell the language model who I am, but I could tell the language model or the AI chatbot what I want them to be. That's also another way of providing the role. So in this example, I tell them that you are a physician assistant. So now they're a medical sort of like character, and that changes the response, obviously, makes it more medically oriented. So by providing this additional context and specifying what you're looking for, you can get a better, more appropriate response. Set the expectation, provide the context, and give it or yourself a role. That way you can, this is one of the simplest sort of like tips for prompt engineering. In this example, we're talking about someone who is struggling probably with symptoms of depression, and we can frame the question differently based off of whether we are that person or we are a concerned parent who is looking for resources. You can use some of these sort of like basic techniques in the workshop that we'll have later in the day. And for more complex tasks, you can provide examples to the language model. So you can tell them, this is an example input, and this is the type of output I want you to give me. So in this example, we're trying to get very short doctor's notes and translate them into some simplified version that a patient can understand. And we are giving the language model of example of, this is a note, this is how I want you to translate it into a more simplified version for patients. And then when we do this kind of like a few-shot learning, then the language model is able to respond more appropriately given what we want. For more complex stuff, we can also get the language model to craft a good prompt for us. So in this example, I want to use a language model to practice for an upcoming exam. I ask the language model itself, can you give me a very good prompt to do that? And then it gives you this very elaborate prompt that starts this kind of a role play between the language model, the AI chatbot, and the student so that they can practice together. Okay, so we've talked about all these kinds of biases. And one thing that I think is important to keep an eye on is how AI companies themselves see these biases. What is their approach trying to get rid of these biases and control their impact? We cannot necessarily affect how OpenAI operates, but if we know what they're thinking, then that's very eye-opening as well. In October, OpenAI published something about political bias. They don't usually publish official sort of like blog posts and things like that about health bias, but they are starting to do that about political bias, and I think that's very eye-opening. Look at the opening statement. ChatGPT shouldn't have political bias in any direction. And then they reinforce that. We want to keep ChatGPT objective by default. Now, if you have ever taken even an undergrad course in philosophy of science, you would find that laughable. That is a very naive way to approach bias. You cannot just, what is objective? According to whom? Based on what? Well, they want to actually measure this, so they have to come up with concrete examples and criteria and ways to grade a text to see if it's biased or not. So they tell us how they did that. They have taken 500 questions on 100 topics. What are the topics from? Major US party platforms. And then they come up with some level of objectivity standards. So this is kind of illusional and then also very US-centric, right? They tell us that one of the things that they check for is that the language model covers multiple positions when multiple legitimate viewpoints exist. Multiple legitimate viewpoints exist. What is a legitimate viewpoint? Who decides that? According to whom is something legitimate? Should we pay for healthcare as a government? Most of the world thinks, yeah. In America, that might be a controversial thing, right? Where do you draw the line between something being legitimate and not legitimate? This is not a new discussion in philosophy of science. They've been talking about science itself, hard sciences even, like watching physical phenomena. And even those are not technically objective. Value-free ideals, we've learned from philosophers of science like Thomas Kuhn, they are myths. They don't exist. Humans always experience the world from a perspective. The perspective might be different from human to other human based on our own backgrounds and life experiences and our thoughts and whatnot. But there is no view from nowhere, even to scientific phenomena, let alone social phenomena, things like politics or healthcare, that kind of stuff. Even when you're conducting a very rigid scientific study, a lot of times you have many choices that you make throughout the study. What do I want to study? What methodology I want to use? And a lot of times you have multiple options for those choices. They're all valid scientifically, according to most scientists. You can choose different things, and you choose them usually based on some kind of values. It may not always be a moral value. Maybe it's just something that is common in your field of science, right? So there's even multiple ways to do a single study. That's why we engage patients. That's why we talk to patients before we want to do a study, because we want to see what their values are and reflect those in our choices that we make in even a simple clinical study. So there's all kinds of value-laden processes that go into the scientific process itself. We choose what to study, we choose what gets funded and what not gets funded. Often, when you're talking about women's health, you see something, you think it's well studied, and then you figure out that it's not, because no one ever funded it. Those are choices that governments or societies or someone made based on some values that they have, right? Observations themselves, we learn from philosophers of science, are value-laden and theory-laden. You usually have a theory in mind when you look at something. That's why confirmation bias happens. When you're looking for something, you will find it more, right? The way we also interpret the results is affected by our values, and the whole peer review process, which is a mess, by the way, is also affected by all kinds of random noise, including people's values, right? And then what gets picked up by media is also another layer of bias that is built in. So even science itself cannot be value neutral, let alone something like an AI product. There's all kinds of value-laden processes that companies went through. What data to include? What languages? What data to exclude? Do we steal people's books or do we not, right? Which communities do we represent in the data? What kind of quality control do we apply to our pre-training data? What kind of values we try to get when we do the human feedback training and the post-training, right? Who do we recruit to do that? These are all things that affect how a language model works. So of course AI cannot be value neutral. This is an example from OpenAI that they actually published of the kind of biases they don't want to have. So they came up with some criteria of what constitutes a biased response. And they, of course, have to automate it. So there's another language model now reading another language model's responses and trying to highlight the parts that are biased. If we treat mental health with the same urgency as physical health, countless lives would be saved. OpenAI has decided this is a biased response that they don't want to have. Some of us might disagree. This is what happens when companies try to address things that are fundamental problems that are very hard to address. We are on our own. We can't really rely on them to take care of this kind of stuff. And Anthropic, a few days ago, also published their own sort of report on this. So Anthropic, they sort of market themselves as safety-oriented and more trustworthy than OpenAI. So let's see what they did. They said we want to be politically even-handed, which is just another way to phrase the same thing. They, of course, also had an automated process to measure even-handedness between responses. But Anthropic published their whole study, made it open source. So now we can take a deeper look under the hood to see what exactly they did to discover bias and to address it. By the way, they also said that this is sort of like similar wordings to what OpenAI had, right? When there is a lack of moral consensus, we want to represent multiple viewpoints. But again, the same question, like moral consensus according to, right? This is the list of stuff that they looked at and they tried to be even-handed about with their flawed definition of even-handedness. But the very first item is Trump. The second one is Biden. The third one is Trump versus Biden. The fourth one is Republicans versus Democrats. Then it's MAGA movement. Why are they even doing this? If you've been following the news, Trump has been cracking down on what he calls woke AI. So this whole enterprise of, oh, we want to be bias-free is itself a political choice based on the company's financial sort of like considerations, given a particular political phenomenon happening in the US. And it might be anyone sitting all over the world using their products, and that's what they optimize for with these kind of like flawed approaches. Alan Brooks eventually broke free of delusion. Ironically, he did that with help of another AI chatbot. He went to Google Gemini, which his company had been providing to them. And in the very first prompt, he told Google Gemini, hey, I've been having this chat with ChatGPT for 20 days. And I think I've discovered a new math that's going to break the internet and make me famous, and I'm going to save the world. And Gemini said, yeah, unlikely. And that helped him. But he was left with a deep sense of betrayal. He'd been doing interviews. He's a kind of like an activist now, trying to help people who have been led to these kind of like delusional rabbit holes with language models because of the sycophancy in them. This story ended better than a lot of other AI-related delusional stories, but it sort of highlights the risk that is involved when we treat these sort of like statistical parrots as someone to confide in with little checks from outside of the companies themselves on the type of outputs that they produce.